All right, so we're going to go back and forth here. All right, so when you played the first animation, right, all the way back in the first screen, what did you see? Very simple. Don't overthink it. What did you see? Okay, the turtle lane 1 had a start of the turtle lane 2. What also happened? Who won the race? Yeah, turtle 2 won the race, right? So something like that. Okay, now when you saw the race, the times, so if this was the speed of turtle 1, remember he had a head start. And this is the head start. At 0 seconds, he was 6 feet in. So what would lane 2, if at 2 seconds in, what would the lane 2, the blue turtle, where would he be at? 2 seconds, where would, if this turtle's at 8 feet, where would he be? 6, right? Because if you saw do the simulation, right? Remember over here? So if you drug this to 2 seconds, you can see right there he's at 6. And at 3 seconds, he's at what? 9, right? So what do you notice about these two, the turtle in lane 1, the turtle lane 2? What do you notice about the numbers? Yep, these are going up by +1 every second, right? And these are going up by, okay. So we call that something in math. Does anyone remember what it's called? When it's going up by the same thing every time? Excellent. A constant rate of change. You'll see me abbreviate it. I do it this. I call it this. The crack. Easy to remember. Okay. All right. So on the back page, or I should say the next page there. So it says, using your table, what is the speed of the turtle? The blue turtle, the one in lane 2. What was the speed then? It was 0, 3, 6, 9 were the times. What would you get for the turtle's speed? Nobody got that one? Yeah, he's going 3 feet per second, right? Because for every second, right? At 1 second, he's at 3 feet, right? At 2 seconds, he's at 6 feet. At 3 seconds, he's at 9 feet. And if you solve that, because that's basically what the table was showing you, right? It was increasing 3 feet for every second. That's what the table was showing you. So that's hopefully how you explained your answer. All right, now a new turtle enters the race. Okay. If you notice that turtle finished in 8 seconds, right? Little big screen here if I can. Yeah, I can see the whole thing. So 8 seconds is right up here. That's when he finishes, right? So I need to draw a line. I'm going to use you probably just use a ruler. I need to use a straight line tool here. I'm going to go up there and get my line to my point. All right? There we go. So this is lane 3. So if you were just to look at the graph from right here, who finishes first? Lane 2. How can you tell it's lane 2? Yeah. Remember, this is the distance. The distance is here, but the time is going this way, right? So you can see the closest to the 0 finishes first, right? There's second, and there's third. Okay, you can see how those lines go up. Okay. So who is faster Lane 1 or lane 2? Who was faster, lane 1 or lane 2? I'm sorry, lane 3. Lane 1, lane 3. Lane 1, right? He finishes faster. He finishes in 6 seconds. Lane 3 finishes in 8 seconds. Right?
But one got a head start.
Right, but didn't ask you about the head start, right? Oh no, sorry, you're right. So if you calculate speed, which is going back to your table, right? What is the speed of the turtle in lane 1? Anyone know? Well, he started at 6, right? But what's it going up by every time? He's going 1 foot. So lane one is going 1 foot per second. That's the speed, right? He starts at 6, but at 1 second he's at 7, at 2 he's at 8, at 3 he's at 9, right? What about turtle 3? When you did the simulation, it's going by 1.5 feet per second. So actually, turtle 1 finishes first, but actually lane 3 is faster. Turtle 1 just had a head start. Probably too much of a head start. So if we write an equation, now this is where it kind of stumped a few people when you saw it. So if you put an equation down here, it'll give you the speed of the other turtle in lane 4. It'll put them into place. So let's see, if I did this, who's the fastest turtle here? Just by looking at the equation. Lane 2, right? How can you tell? Why did you say lane 2?
It's going faster per second.
How do you know? Because of the 3. In the equation, that's where the constant rate of change is. So who's the second fastest turtle according to this? Just pure speed. Lane 4, because we wrote 2t, right? And then it would be the 1.5, and then this guy at 1. Okay, in terms of pure speed. We didn't say who finished first, right? So if I go back to my thing here, and I go over to the screen, and we type that in, it's going to let me type in the D. I'm just going to go to the computer real quick and type it. So if I type D equals 2t, now when I play the simulation, there you go. So there's the fastest turtle. So even with the head start, he tied lane 1. See that? Okay. Now, we can manipulate that. We can make the equation, what if I did 4t? What do you think is going to happen now? Who do you think is going to win? Lane 4? Look how fast he goes. Because we increase its speed. Okay? Because we increase its speed. Okay. Now the next one, you can create your own. All right, so when you drew some lines, okay, you can kind of create your own. But again, the steeper the line, okay, so a line that kind of goes out more like this is a slower line, okay, is a slower turtle than one that goes up like this, right? The steeper the line, the higher the constant rate of change is, which means the faster we'll go according to the races. So again, a line that you see is really, really steep like this has a high number, whereas as it flattens out, the number gets smaller and smaller and smaller and smaller. As you get under 1, where you have to deal with fractions, those numbers like almost, it's not a flat line, so the straight line is, the slope is 0. So anything just above 0, the lines are pretty flat, but on just a very slight diagonal. All right. So let's answer the last part here. So this graph shows the distance versus time versus time relationship for lane 1 and lane 2. So those are the equations, right? So which statements did you check? The lane 1 turtle has a head start. How many groups check that one? Yeah. It start right? This. Okay? In an equation, we actually call this is the y-intercept. So when the turtle's not moving, that's where it starts. So right here. Okay? Did anyone check at 12 seconds, lane 1 turtle's distance is 6 feet? No one checked that one? Yeah, if I plug a 12 into here, what's 1 times 12? 12 plus 6. 18. So it's not. It's 18. Okay? So, yeah, you don't check that. Lane 2, turtle, is faster than the turtle in lane 1. How many people check that? You should have it checked. Lane 2 speed is 3 seconds. Lane 1 is 1. So it's faster. Now at 3 seconds, lane 2 turtle's distance is 12 feet. That's right here. Is it 12 feet at 3 seconds? What is it? If I plug in a 3 for this time, what should it be? 9. So you shouldn't have checked that. So box 1 and 3. How many people will check box 1 and 3? All right, good. So summarize. I know time's almost up here. So do the relations seem to be linear or nonlinear? Okay. What do you say? Well, they're actually all linear. Why are they all linear? Because they all have a constant rate of change. Even though lane 1 was slower, they went 1 foot per second, right? That's a constant rate of change. They just started somewhere different. Lane 2 went a little faster. Lane 3 was a little faster than lane 1, but they all traveled at the same rate per second. So these are all examples of a linear model. So that other sheet that I gave you is homework.